Yeah, so we talked about RC impedance or RL admittance. So we talked about this topic where we found out if the function is RC or RL, if the function is written right. So if this f of s is impedance function, then you can realize the whole function using Foster 1, where all the quantities will be coming in series. You can see that all these terms are getting added, so those terms will be in series. So Foster 1 will give you series combination, but when you are doing this, it will be RC function. And to realize this, we have considered that f of s is an impedance entry. Then you can realize such function. However, if it is admittance, we can realize with Foster 2, and in that case this will become in parallel, and the entries will be R and L, not R and C, right? This already we talked about this. Now so there are some properties, as we have told, right? Three properties are there, so they have to be on negative and real axis, and they have to be alternate. If they are not alternate, you cannot synthesize RC, RL or LC function. So using these three properties, you have to tell me whether, like, what about these four functions? Are they synthesizable using RC impedance and RL admittance? Is it possible? First, first no. Okay. You can see like it's a red colored mark, so all are not possible, and green is possible. Right? So the reason is they are not alternate, right? In all three, which I found out from Franklin Kuo book, so they are not alternate. That's why they are not synthesizable using RC impedance, RL admittance, or RC admittance, RL impedance function. In any way, it's not possible. So they have to be alternate. So now we also talked about admittance of Foster 2 form, which was giving me parallel combination. Now let's assume that we have a function which looks like so. Now you have to consider this f of s as z, its impedance function, and you have to realize using Foster 1, let's say, because this is impedance, so it will be Foster 1. If it is technique which is Foster 1 or 2, you need to use partial fraction method, and in partial fraction method you are going to realize the whole thing with the residue theorem. So can you find out those entries very quickly? First of all, you can see that there are two possibilities for realizing RC or RL function that needs to be checked. If numerator and denominator both are same, then there might be the case that you will have DC entry will be there, right? So DC entry means at zero frequency some element is available which is equal to 3. If you keep j omega equal to 0, you will see it's 3 here. Yeah, 8. So that way you can, however, this is not a unique solution. This might be like you may have 2-3 different solutions. Okay, this is also one thing I'm telling you. You may have different answer. Okay, so can you find out through the partial fraction? Can you find out this in your notebook? Or as suggested by maybe by this book, you can do this one also. This is also possible without finding any entry at DC. So there are two possible answers are there. Let's follow the book. So as per book, you can find out K1 and K2. What will be K1? Yes, Pawan. Pawan. Yeah. Okay. So what will be the K1 value? Look, if you are interested in finding out residue at S, this will be removed and replace all the S entries with 0. So it will be 8, right? So 8 will be there. In this case, you can write down quickly 8 by S. And K2, so Pawan, now can you do what is K2? K2 is a residue at S plus 3, means S equal to minus 3. So you need to remove S plus 3. At the place of S, you need to replace minus 3. So what is the answer? 1. Okay. So now can you draw this circuit very quickly? Sorry? It won't be equal to infinity? K2 is wrong, you mean to say. Okay, DC value. Yeah, it has to be some DC value also. Okay, so what is the final answer? Here K2 will be 1. Okay, and what about DC value? Yeah, 0 dal. Is it coming 8 or something else? Okay, if it is coming 8 and you check whether it's giving the same answer or not. Through DC also you can find out, by the way. That is also possible thing. Plus 3 RI, then it's fine. That is also the correct, that might be the correct answer. Let me see. But if we are told it's wrong. A constant term is 3, you mean to say. Okay. So if this term is correct, let's draw the equivalent circuit. If this is using Foster 1, DC value is 8. You just check whether it's coming or not. Yeah, numerator is S square. Ah. I made any mistake? Yeah. Why it's not? Hmm? Oh, okay, okay. I forgot to add that. Okay, okay. I forgot to add this. Yeah, so this is correct. This is correct. Pawan, right? Yeah, so it's DC value on this side. Okay, so I need to check because it's coming DC value, right? Oh, DC value is 8. Okay, okay, okay. Okay, sorry. Sorry. So, okay, I rephrase my sentence. You have to find out through partial fraction whatever is coming here. You should call that one as at DC. That component is available at DC because other components are not there. The capacitor is a DC blocking capacitor, right? It will block DC. So capacitor cannot be there, right? So can we draw this one? First will be 3 ohm, next will be combination of these two. So is it, can you tell me what will the combination? So capacitor and resistor, the value of capacitor will be 1 farad and this value 1 by 3, right? So yeah. And here it's a capacitor, whose value is 1 by 8 farad. Then come back. Same thing I want to realize using Foster 2, then I have to consider this function, whatever you have achieved, I need to call that one as admittance. And admittance will have all three entries in shunt. So this is 1 by 3 ohm, this is resistor and capacitor, and there will be, sorry, capacitor, it is an inductor, and this is again an inductor. Inductor value is equal to 1 by 8 Henry. This resistor value, what do you think about this resistor value? 3 ohm, and this will be again 1 Henry, right? So that's fine, right? So we have found out these things. However, we are interested in finding out two more things which are known as coir 1 and coir 2. As we know that Foster 1 is dealing with impedance, Foster 2 deals with admittance. However, coir 1 and coir 2 are not restricted to admittance or impedance. However, they are using something called continued fraction, expansion. For that, we are going to divide in coir 1 from higher order side we are going to start with, and this side we are going to start with the lowest order, and then we will make the division. So if this is the transfer function, 3s square plus 18s plus 24 divided by s square plus 3s, let's assume that we are doing coir 1. So Akshita, can you do the coir 1 division on board? You have to do it on board. This side, please come. Pawan, can you do coir 2 this side? Coir 2 this side and coir 1 Akshita will do that side. Which side do you like, right or left? And Pawan, can you do coir 2? So coir 1 will be the division of like these two terms, but you are starting with the highest number, and for coir 2 you are going to start with the lowest order. Then maybe please ready with the circuit. Maybe Vaishali and Swarna will draw the circuit, right? this side you can see. In TV you can see what I am doing here. Hmm? 9s. Right? And this will not be minus 24, plus 24. Oh, I am saying. I made any mistake? Or? Which one?
So 1 by 3.
Yeah. Okay. 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 Then 9 by 3, right? No. 27. Right. Then it's 9s. That's done. Then 24 by 3s. Right. Done or not? Okay. Do you need my help, Pawan? I'm not able to see there. So Gaurav, he is doing correct. देखो तो. Right. Arun can help you, no problem. It's very easy. It's all about practice. Look, you all are JE qualifier, right? You must be faster than me. So that's done or not? Yes. This is correct, Swarna. Swarna, please take care of this term, coir 2. Vaishali, please take care of coir 1 because you have to draw the circuit. I could not see. I cannot see from here, so it's reflection. Okay. Okay. So you have done this one. So Dhruv went for चश्मा बनाने चला गया क्या? Dhruv. Okay, now so Vaishali will draw the circuit. This is correct, right? You have to go till 0. No, no, it has to be 0 here. No problem. Vaishali will do that. No problem. Yeah, you need to find out the last quantity also. You need to multiply with. Again, I made mistake. 1 by 3. Okay, this is not 1 by 9. This is 1 by 3. Okay. Swarna, can you do that side? Hmm? You have to tell. So, okay, Swarna, can you do it here? You both can go on board, no problem. Divya and Swarna both can try, not a problem. So in this case, how can we write down the transfer function now? 3 plus 1 by s by 9 plus 1 by 27 plus 1 by, yeah, 1. No, you look at this in the screen. Am I right or wrong? Okay, 27 by last is s by 72. 24 3s are 72, no? Yeah, so s by 72. S by 72. So Laplace operator is in numerator, not in denominator. So first entry is resistance or transconductance. What is that? Look, it cannot be capacitor. No, not that side. Let's acquire. Yeah. So first one is resistor. Okay. Just giving you one hint. If you are making coil 1 and coil 2, coil 1 in LC, it looked like this one. It is not series or parallel combination, it's like this. If it is coil 2, it's like this. Right? But in the case of RC, you are going to see this one. Right? And so on. In RL, you are going to see such entry for coil 1. This is all these left sides are coil 1. Coil 2 in RC, you will have. Yeah, what happened? I'm not able to see. Okay. Is it correct, Gaurav or Piyush? Okay. So I'm giving all the hints. Yes, Vaishali. Okay. So you are on the right track. So R and C. R value is 3 ohm. Please do not forget to keep units. I'll deduct the marks. Please do not forget to keep the units. Yeah. सही है, then fine. Okay, fine. Yeah, fine. This is correct or wrong? This is 27 ohm. This is 1 by 9 farad, 1 by 72 farad. Okay. But you are getting 17. Okay. Okay, fine. And this one, we have to see the first entry as, okay, fine. As an inductor, second is the resistance, right? This way she would have found out starting with 8 Henry, right? Huh? Okay, 8 by S will give me, yeah, if it is Z of S, then this will give me the capacitor in that case, right? Okay. Partial fraction method where it is. So this is the answer for Pawan and Vaishali, and this is the answer for Swan. No, is it? Oh, this is a, we have not solved actually what we have. This is correct. What Swarna has found out must be correct. Starting with capacitor, right? You got the capacitor as the first entry. So that's correct. What has been done in Franklin Core book, it's different thing. Why RL and C? So first entry is capacitor, right? Can you tell me the transfer function? Then I can do that. 8 by S plus 1 by 1 by S plus 3. Okay. Then okay. Then it will give definitely RLC. RLC will be there. RLC you are okay. Then it's correct. Then it's correct. So here the expansion has been done with the fact that this is impedance. In book what they have done by considering that as Y. In one case they are considering Z, and one case Y. So both the results will be different. Like procedure is same, but results will be different. But this does not have any name. Unfortunately, coir 1 and coir 2 are defined with these circuits. Coir 1 and coir 2 are defined with these circuits. If you have been asked to find out the Foster 1, then it's a series combination. Foster 2, it's parallel combination. However, if it is coir 1 and coir 2 for LC circuit, it will be look like this one, LC LC. If it is RC, then it's RC RC. If it is RL circuit, it start with RL RL. But in the case of coil 2, the entries will be swapped, like capacitor, inductor, capacitor, resistor, and inductor, resistor. I'm telling you, they are only and only coil 1 and coil 2 depending on their systematic entries. If you are saying something else, RLC, it's not coil 1, coil 2, or foster 1, foster 2. It does not have any name. That is what I'm trying to tell you. By wrongly placed, I kept some wrong question for you. Which one? This one. 8S. Oh, it has to be 18S. Okay. Okay. Anyway. So this is the way we can find out coir 1, coir 2, right? By the way, this is also known as coir 2 entry, but coir 2 entry does not have inductor at the beginning. Right? Coir 1, coir 2 does not have any systematic entry. They only define it has to be like this. If it is LC, L has to be first, capacitor has to be second. It may be anything. There is no coir has not defined it has to be impedance or admittance. If you can get such diagram with impedance or admittance, they will be known as coir 1. If you are getting these diagrams either considering impedance or admittance, they are considered as coir 2. Yes, if it is not told to you that what you have to do, right? Okay, so now it's similar to what we have studied, just the name has changed. Earlier we were studying RC impedance and RL admittance. This is what the previous topic we have covered. Whereas in this particular topic, we are going to see the transfer functions which are going to have RL impedance and RC admittance. But there is some interesting property is going to happen here. So note that property will make this function as RL impedance, and it's make different from other entities like LC and RC. Okay. So as we have written the function for RC, we can write down the function for RL, where this is L If this is impedance function, then the first entry is inductor, second entry is resistance, right? And these entries will be what? It's resistance and inductor. If you divide this, it will give me 1 by S by Ki plus sigma I by Ki, right? Actually, this whole function is impedance function. When I'm taking 1 by, it becomes admittance. So this entry becomes uh, capacitor or inductor. Then it's capacitor. Hmm? Oh, I made a mistake here. That's why we got the wrong answer. So it's 1 by Ki plus sigma I divided by Ki times S, right? So first entry is resistance, second entry is inductor, right? So resistance is 1 by Ki ohm. It's Ki ohm, right? And this will be Ki by sigma I Henry, right? This is fine. And same thing will go on. But in the case of this one as admittance function, all these entries will be in parallel. So first entry will be a capacitor whose value is K infinity farad. Value of this one is K0 ohm. Sorry, 1 by K0 ohm. This is admittance. And this guy will become admittance. So there are two series combination. One is resistance and one is capacitor. Resistance entry is 1 by Ki ohm, and this is Ki by sigma I farad, right? Yeah, so you, if it is f of s which is not defined, I'm telling you the generalized equation. If it is impedance, what is going to happen? If it is admittance, what is going to happen? In the case of partial expansion method, right? Because through partial expansion, you're finding out k0, k infinity, k1, k2 and all such entries. Means you are finding out these things using whatever the techniques you know, or maybe you are using the residue theorem, through which you are finding out all the residues, and then you are drawing this. But there is another technique where you are using continued fraction method, through which you are finding out the entries which will look like something like this, yes, plus something, right? Which we already, or let's write it down in general way. It will be like this: q1 plus q2 plus 1 by q3 plus 1 by q4 and so on. So there are two possibilities. In both the possibilities, this function might be impedance, admittance. It might be impedance or it might be admittance, right? So if it is impedance, it's making RL circuit. If it is admittance, it makes RC circuit. So RL circuit is possible by making or considering this f of s as impedance. So we are going to call this one as RL impedance circuit. This one we are going to call it RC admittance function, circuit. And that is the reason why we call the topic name as RL impedance and RC admittance. And similar to the previous case, we got RC impedance and RL admittance by considering f of s in one case impedance, one case admittance. Is it like fine or right? So using this partial fraction method, you are getting two different results. One is called Foster 1, one is called Foster 2. Foster 1 is series combination and Foster 2 is parallel combination. And that's how the names came. However, in continued fraction method, you might have RC and RL might not look like what you want. But if you are seeing such kind of function, or the diagram look like this one, you are going to declare that one is coil 1 RL circuit. If it is like this, you are going to declare that one as coil 2 circuit. Same for other case, all inductor will be replaced with capacitor, and you are going to call that one as RC coil 1 function, and in this case you are going to call coil 2 RC function. Look at the position of capacitor and resistor. That is how it's defined, right? Okay, so if we are looking at the RL impedance functions property, other things are very like similar one what we have studied. Poles and zeros has to be on left half plane, right? And they have to be in alternate mode. So this is also fine. You are seeing at zero frequency you are seeing somewhere inductor, and at resistance also you are seeing. So those things are fine, but the residues of the poles must be real and negative. Till now we have observed that when we are doing all these things, k infinity, k0, ki, all the things were positive only. And if you are saying anything negative in the case of LC or RC impedance or RL admittance function, all these entries were positive till now. But here, surprisingly, you are going to see negative. This is all because of how you are keeping the like you are keeping your function in the form of Foster. That's why it's going to happen. But still, remember, if your residues are negative, you cannot synthesize the circuit, because if it is minus 1 by L minus 1 by 3s, and if this is your impedance function, you cannot say that it's a negative. How to like implement negative capacitor? It's not possible. Till now you have not learned how to make the negative impedance or negative admittance. That might be like taught in other course afterwards when you are going to use the transistors. But here using passive, it's not possible. So although we have this property, then you have to do some arrangement so that you will get plus entry. That's what we are going to learn. So let's see what is happening here. You have basically this transfer function. Can you write down this transfer function in following entries? Can you try this? Because numerator and denominator are both are same, so you may have some entry at origin or at DC value. It might be 2. So if you're getting negative entry, do not afraid to tell it's negative. What is K1 is minus 1 by S plus 2. So we can, so you can see here it's 1, 2, 3, 6. Those poles. And what about this one? Is it minus or plus? Minus 15 by 2 S plus 6. Right. So we cannot synthesize such function, but there is a trick through which you can synthesize this function, or you can make all these entries plus. How to do that? That technique says that you have to divide this function with S. So can you do this? Divide this entire function with one zero pole at origin. Can you do that? Like this. And now find out something like this. Just to get the positive entries. So this is a you have to use this technique when by chance you are getting negative entries. If you are getting negative entries, you know that your function is RL, and then you have to do this one. So this is a trick through which you will get all the positive entries. So first we are going to divide it with S, then we are going to multiply whole function with S so that it's same. So can you find out this? Okay, so we reached here. So can you find out this K0, K1 and K2? Are you getting positive entries? Right? So, okay, any question? Yeah. Yeah, so it's a trick. Right now, it's a trick. I'll remove that pole afterwards. It's a trick to remove all the negative entries. It's playing with the maths. That's the only thing. But you have to use this technique when you are seeing all the negative terms. Hmm. No, no. Look, if you look at, if you derive or if you try to find out the property of this function as realizability, means Hurwitz and positive real function, all are satisfying. If everything is getting satisfied, then I'm telling you, in the entries all have only single pole at particular frequency. Then if you are seeing negative entries, then there is a trick to make this function in positive side. So we'll make it. So just follow what I'm saying right now. Then you will see at the end positive entries. So are you seeing these entries? Are you seeing these entries? Now the next thing is already we have divided with S. That was not the original question. The question was this one. So let's multiply all entries by a Laplace operator. This is fair enough, right? Now still things are pretty much fine in our hand, right? Because this is same thing. Yes or no? Gaurav, now it's same. Now can you synthesize using RC or RL, whatever it is? This is also known as Cauchy's theorem. It's an extension of same. I'm using that. If if you remember earlier, we told that you will take the derivative. If you remember, if you got some multiple poles and zeros, so it's one corollary which has been derived from there, right? So this is a technique again came from residue theorem. Okay, but it's easy, right? If you are getting negative terms, and if you are sure about this function that this is positive real function, if this is positive real function and if you are seeing negative entries here, then you should apply this. If this is not positive real function, it's not at all synthesizable with any technique. It's not synthesizable, right? So can you draw this function? Assume that this is z of s. Yeah, Divyansh, do you want to try? It may be anything. I don't know. You have to tell me, right? The only thing I know, if it is impedance and if I am using partial fraction method, I am going to land up with Foster 1 method where all the terms will be in series. it might be RC, RL. You have to find out and you have to tell me. Right? So is it RC or RL? Okay. That should be known when we have started this topic. I explicitly wrote it's RL impedance. So if it is impedance, it will give me RL. If I make this admittance, it will give me RC. Right? But in general, it's not known to you. Let's say you know because this topic is going on in synchronized manner. But maybe like when the world is open to you, then you don't know whether it's RC, RL, or LC. You need to find out. By looking at single pole, you can see that it has to be RL or RC. If it is function looks like this one, then you know that there should be LC, and you have to check all the properties of LC. Right? So this has to be resistance, resistor, capacitor, and sorry, inductor. So this is what happened. Look, I came without practice. I generally don't practice all these things. I think I know all these. So it happens. If you are in examination, maybe you are making mistake here and there. So please do enough practice so that you will get the correct answer. These are very easy things, but the only thing is you need to do the practice. If you are not doing the practice, maybe you will not get the correct answer, right? So all these entries you can give the answer. However, if this is y of s, if I am writing this y of s, then this function lead to have Foster 2 category where all these entry will be in parallel. So do you want me to like do all these finding out values and all, or should I call someone, or is fine? Rohit, are you following? Can you just draw the circuit and then we'll call it off? Yeah, for if it is admittance on board, of course. Then we can call this off for today. And most of the RL circuits are completed. Just one thing which is left, it's continued fraction method, where you can divide numerator and denominator. Right? So you can divide numerator and denominator. Starting from highest order will give you some answer. Starting with lowest order will give you some answer. Right? And both of them will give you coir 1 and coir 2. You have to look at the how the how all these elements has been kept. So, like, how was the synthesize? It was easy. Are you able to follow what we have studied? Mahima, any doubt or? Yes, Divyanshu. You are Divyanshu or what is your exact name? Devanshu. There was one student who already graduated whose name was Divyanshu. It's he is Devanshu, right? What is the spelling? Divanshu or Devanshu? I. Okay. Is it like this? So what is the meaning of that, Divanshu? Okay. Generally, in like I don't know, are you practicing for somebody want to go for MBA or something after this. So maybe you're going through some. Are, are you going through some coaching or something or no? Okay. So in management rule there is something called if you are drawing very small, tiny circuits and all, you don't have confidence, right? Not okay. Okay. So next time onwards you'll practice. Every day I'll call you. Is it correct or? So this is. So look at those entries very carefully. Okay. Yeah. So this is the correct answer, right? So although like we have three different days are left next Tuesday, Thursday, and Friday. So any one of the day we will have one assignment exam also. Surprisingly, we will have assignment exam so that I can have more number of people at least for last 3 days. Okay, like Desra needs attendance. I don't know. इतना पूरा बोल बचन के बाद ही मतलब